We are still on complex analysis, but this playlist will focus on complex differentiation. So first, we are to define the derivative of a complex function or provide here with its actual definition, and later on use the definition to find the derivative of certain complex functions before we apply some techniques or rules on differentiating complex functions. So it's very important to start here because everything else will be dependent on this. So basically, we have different ways to provide the definition. Allow me to place here the definition of a derivative of a complex function. So we have here if f of z, a complex function, is a single valued function, okay, in a certain region, okay, and a region on our z-plane, the Argand plane, or the complex plane, okay, then the derivative of our given function, okay, f of z, is defined as, okay, we have here the derivative in this notation of your f of z, okay, is equivalent to or equal to the limit of this expression f of z plus your delta z minus f of z is all over your delta z as your delta z approaches 0, provided that the limit exists. Definitely, it should start on understanding that the limit exists, and if the limit exists and it follows this specific idea or perspective, then that is equivalent to the derivative of our complex functions. Take note, we are also using the same notation for a derivative here, and we are using here delta z, which means it's a small change in the complex variable z. Okay, now some references would like to use other variables to make it easier, like we are going to use here h, okay. Some uses h and h here as h approaches 0. You can also use that regardless, because we are going to simplify the given function to find out if the derivative exists or not. But allow me to use delta z because it is more familiar or formal, or I mean it's the closest to what are the references I've been using generally. So again, if the limit exists, then we can say that f is differentiable at z. Now, take note that we also have rules on differentiation, but this is actually the definition itself. So in the next few videos, we'll be using this definition, because take note that as z here approaches 0, take note that the denominator will be 0 here, but we'll be applying some techniques in order for us to show the derivative of a certain function, and that will be for the next few videos. We'll be solving for the derivative of the next few functions using this definition in such a way that we are able to simplify this as this not to be undefined. So we'll have that on separate videos. This is again the definition for a derivative of a complex function, similar to the definition of a derivative of a function under the real numbers, but this time we're using z as a complex number. Thank you very much for watching.